The diagram I'm going to draw now is a diagram that we need to calculate the total currents flowing in the circuit. So the question is very simple. Calculate the total, all right, total currents flowing in the circuit below. Flowing in the circuits below. So let's now draw the circuits. Very simple, quickly. We have something like this. All right, resistor 1, R1 with resistance 2 ohms. Then we have the second resistor with resistance 2 ohms again. Let's see. Okay, another one. Okay, we have this with resistance, that is R2 is equal to 2 ohms. That's what it means. Then we have the third one. Just watch the diagram. We'll have the third one somewhere here. This is the key, right? And then the key is connected to the cell, all right? Let's take chalk. And then from there, from the cell, we have the third resistor offering resistance 4 ohms. All right? So with that, we have been asked resistor 3 offering 4 ohms resistance. Okay? The energy here, no, this diagram, this is not the way diagram is. There is a bicut somewhere here. So I'm redrawing the diagram. This is the confusion they want you to figure out, not this. Okay? Now, where is my duster? Okay, I have my duster here. So this is not included in the diagram according to what I have. All right? So the question is, there shouldn't be any switch here because this is a direct connection, right? The switch should be here. So we have switch at this point, or key, so to say, all right? Most times I use the word switch, most times I use the word key. So we have K for key, right? And then cell E is equal to 2 volts. Very simple. Look at it very well. Ordinarily, one will get confused. May looking at it, but there's nothing wrong with that. So what you need to understand is this. First of all, analyze the circuit and then try to understand what it's all about. So this circuit, without wasting time, once the key closes, current flows, all right? Gets to this junction, split into current 1, I1, and then split into current 2, that is I2. This flows in this form, I2 flows in this form, right? Then I1 flows in that direction, which is this. I1 will flow into resistor 1, resistor 2, and then recombine, emerges at this point, all right? Recombine with I2 at this point. So I2 is going to come to this point, and then flows back to the source. That's what happens. Now we have understood the arrangement here. Then we need to ask ourselves, what sort of an arrangement is this? What would you say? Is it a parallel arrangement of resistors or a series arrangement of resistors? Your answer, I want it be stated in the comments section. Put your answer in the comment section. As you consider subscribing, giving me some thumbs up, and then sharing with your networks, students and friends, putting the bell button on for constant notification, do not forget to comment what you think this arrangement is all about. Arrangement or parallel arrangement. Your guess is as good as mine. Alright, so having said that, we quickly step to Ohm's law. We recall Ohm's law. V is equals to I, and then total resistance we are going to calculate. If we are looking for I, good. That's the current flow here. Total current flowing is I equal to V all over RT. So we have equation 1, equation 2. Then we can as well, since we are looking for I, there's no need extending it to finding RT, because we must find a way to get the value of RT, which is the total resistance of the circuit. So what do we do? You know, I have given this as an assignment or as a teaser. Find out what the arrangement is all about. I'm going to solve. So the arrangement, I guess, is 1 all over RT, which is 1 all over R1, okay, combination of R1 and R2, all right, plus 1 all over R3, okay? So what do I mean by this? It means, first of all, we need to calculate the total resistance in series and then combine with the resistance in parallel. So let's see, it's a combination of series and parallel. So I've answered that. Combination of series and then parallel connection of resistors. Alright? Connection of resistors, so to say, resistors. I want to stop at this point. Alright? So what do we do? First of all, we calculate the total resistance in the series connection. That is RT is equals to R1 plus R2. And by the time we substitute these values, we have that RT for total resistance in series is equals to 2 plus 2, and this will give us 4 ohms, right? For us to calculate the total resistance of the circuit, we have parallel connection formula. That is 1 over RT is equal to 1 all over Rx, okay? That is for series connected resistors, connection of resistors, Rx, and then plus 1 all over that resistor in parallel, right? So that is it. We have established this, so we substitute. How do we substitute? Very simple. We are looking for 1 all over RT, okay? So we can do a very simple analysis here, since we have this to be 4 ohms, total resistance in series is 4 ohms. So what do we do? 1 all over 4, right? Plus the resistance in parallel is just 4 ohm again. Can you see how coincident that is? Okay, let me pick chalk. So if we have that, so what do? We move on. It becomes, we can just say 4 times 4 all over 4 plus 4. And this will give us 16 all over 8. In summary, RT, that is total resistance offered in the circuit, is equal to 16 all over 8 is going to give us 2 ohms. So 2 ohms is the total resistance offered in the circuit. We cannot quickly find the current. Total current flowing I is equal to V all over RT, which has been established. The value of RT has been established. Once again, if you have watched up to this moment, it's time for you to consider subscribing, right? Give us some thumbs up. Put the bell button on for constant notification. Do not forget to share with your networks, friends, and students. Back to it quickly. We have that the voltage given is 2 volts. The total resistance is 2. So total current here is equal to 1. Therefore, we have found the total current flowing in the circuit to be 1 amp. Good. The total current flowing in the circuit, in this big circuit, is just 1 amp. Very simple. We have come to the end of solving this problem. Yes. Yeah. So I want to thank you so much for your patience and for watching up to this moment. My next will be linked up there for your learning pleasure and for gaining knowledge. Thank you so much. If there is any part of this video that is confusing or steps that I outlined that is confusing, please do me a favor by putting it in the comment section, and I promise to address that section in my next video. See you in that next video.